Hey students, this is lesson 11.4. We're going to learn how to add and subtract rational expressions. One thing to remember here is that when adding fractions, which is essentially what rational expressions are, you need a common denominator. So quick little review here. Go ahead and do that and I'll check back with you. Alright, you can add rational expressions with the like denominators just by adding the two numerators together and put it over the denominator. So that's not too hard here. All we have to do is add the 2 plus the 1 and use the denominator 5a, and so we get 3 over 5a. Of course, there'd be some restrictions on a, but I think we know that well now. Again, here we have a common denominator, so let's just rewrite it with one denominator of x plus 4. And then add the two numerators together. And so we get 10p over the quantity divided by the quantity x plus 4. Alright, so go ahead, you try that. Alright, and when we're subtracting, just one thing to keep in mind, you're actually subtracting this quantity here. So if I rewrite this expression, I'm going to have 3x minus the quantity 2x plus 1 all over 5x squared plus 9x minus 2. And when you simplify that, you have to distribute that negative sign. So I get 3x minus negative 2x would be the same as plus 2x, and then minus 1 divided by 5x squared plus 9x minus 2. And then bring that over here. That's equal to 5x minus 1. And I'm going to go ahead and try and factor this expression. See if we can cancel anything here. And the way I would factor it is I would multiply 5 times negative 2, which is negative 10. And I need two numbers that have a product of negative 10 and a sum of 9. And that would be 10, positive 10, and negative 1. So I'm going to rewrite this expression here as 5x squared plus 10x minus 1x minus 2. Then I'm going to factor the 5x out of the first two terms, so I get x plus 2. And then I'm going to factor negative 1 out of the last two terms, and I get x plus 2. And so this factors into 5x minus 1 times quantity of x plus 2. So that's my denominator over here. 5x minus 1 times quantity x plus 2. And now we have a common factor that we can simplify a little more. Cancel that, and we get 1 over the quantity x plus 2. Alright, go ahead, you try that. Alright, to find the least common denominator of two rational expressions, first write each denominator as a product of prime factors, then use each factor the greatest number of times it appears. So what we're talking about is 9x has the factors 3, 3, and x, and 3x squared has the factors 3x and x, and so we need a factor of 3, and we need it twice to handle 9x, then we need a factor of x, and we need it twice to handle x squared, so we need 3 times 3 times x, which equals 9x squared to be our common denominator. So we need to change now our fractions so that their denominator is 9x squared. So to do that, I have to think about what number am I multiplying 9x by to get 9x squared? And to get 9x squared, I need to multiply it by x. So I'm going to multiply the numerator and the denominator by x. And then in the second one, I need to multiply to get, I have 3x squared there, so I need to multiply that by 3 to change it so that the denominator is 9x squared. So I'm going to multiply 1 times 3 for the numerator and 3x squared times 3 for the denominator. And now I have 2x over 9x squared plus 3 over 9x squared. And now I can just add the two numerators together. 2x plus 3 divided by 9x squared. And there is my answer, and it should be simplified because I used the lowest common denominator. I'll let you try that. All right, what is the difference? So now we're subtracting, and notice we do not have a common denominator, so I'm going to suggest this little property. If you have a over b plus c over d, and I think you should write this down, that's equal to a times c plus b times c divided by b times d. And that all that's doing is saying that we're going to use the denominator b times d as our common denominator, not necessarily the greatest or the lowest common denominator, but at least the denominator. So in this problem, I'm going to take 4 times quantity x minus 3 minus 1 times quantity x plus 2, and I'm going to divide that by the quantity x plus 2 times x minus 3. And I'm going to simplify the numerator by using the distributive property, and I get 4x minus 12 minus 1x minus 2, and that's still the same denominator, x plus 2 times the quantity x minus 3. Simplify the numerator, 4x minus x is 3x, and minus 12 minus 2 is minus 14, and then the denominator is x plus 2 times quantity x minus 3. And there are 3x minus 14 can't be factored anymore, so that's in simplest form. All right, I'm going to let you try that. All right, one more problem here. Using rational expressions, we're going to represent the total time it takes to ride downstream and upstream. And usually when you're going upstream, it's a little bit harder because you're going against the current, and that's the case here. The idea here is that if you take your distance divided by your rate, that's going to equal your time, and that's what we want. But we need a total time going downstream and upstream, so we actually have to add 2 times together to get our answer. Our time downstream plus our time upstream. All right, now let's just let our, it tells us let S be your speed downstream. So our speed downstream is S, and our distance downstream is 3. So our time down is our distance divided by our speed, so that would be 3 divided by S. So that's what we have for our time down, 3 divided by S. And then our upstream, now here we're going against the current, it tells us that our speed is reduced by 40%. Well, if you think about that, if your speed is reduced by 40%, that means you're going 60% of your downstream speed. So I'm going to represent that speed as 60% times not x, but s. So 60% of the speed that I would be going downstream is my upstream speed. And the distance is the same, so the time for that is going to be 3 divided by 0.60 s. Now, to get my expression, I just need to add those two together. And then I'm just going to simplify it. I'm going to find that common denominator. Actually, I'm going to use that property I just showed you where if you multiply 3 times 0.60 s, plus 3 times s, and put that over 0.60 s squared, that's how we can represent the total time. And I'm just going to simplify it. 3 times 0.60 s is 1.8 s plus 3s divided by 0.6 s squared. And simplifying a little more, that's the same as 4.8 s divided by 0.6 s squared. 4.8 divided by 0.6 is the same as 8. And s divided by s squared is 1 over s. So my final expression is 8 divided by s. All right, I'm going to let you try that. Lesson check.